This graph maps the projected global cost of cybercrime, scaling from $10.5 trillion in 2025 to $15.63 trillion by 2029. This volume requires massive infrastructure, supported by an industrialized ecosystem operating with corporate precision through professional syndicates and service pillars. These syndicates run on a globalized supply chain. They coordinate bulletproof hosting providers, register rotating domains, and utilize frictionless payment rails to move capital across borders. The accelerant driving this scale is the deployment of Agentic AI. Agentic AI refers to artificial intelligence systems capable of setting their own goals, making decisions, and acting independently to achieve them without human prompting. Traditional AI models require linear inputs. A human operator types a prompt, and the machine provides a static output. Agentic systems observe their environment, form a plan, and execute multi-step operations on their own. In a cyber attack, these autonomous systems can execute the entire lifecycle. They handle initial reconnaissance, generate payloads, move laterally through a network, and exfiltrate data, all while the human attacker remains entirely hands-off. Because the execution requires no manual labor, a single malicious operator can now deploy a massive swarm of these autonomous agents, pointing them simultaneously at a specific enterprise target. This orchestration is already extracting capital at scale. In Hong Kong, a multinational firm lost $25.6 million when an employee was manipulated into transferring funds by a coordinated swarm of deepfake video avatars acting as company executives. Static biometric verifications and traditional network perimeters are structurally unequipped to block these attacks. They rely on catching known signatures, while these systems operate at machine speed, altering their tactics in real time. Securing the enterprise in 2026 requires abandoning reactive, static perimeters. Defense must match offense, utilizing proactive, agentic orchestration to identify and neutralize threats autonomously. This flowchart illustrates the modern entry point. Attack chains consolidate around infostealers, focusing on bypassing perimeters and extracting session cookies. This automates the hardest part of the breach. Once inside, credentials are automatically handed to a secondary agentic system. Once the agent is inside, it engages in VIB Packing. This is the adversarial use of generative AI to perfectly mimic authentic user behavior, matching the exact rhythm and baseline traffic of the network it has compromised. By wrapping itself in legitimate behavioral patterns, the autonomous AI blends into normal operations. Security systems scanning for known malicious signatures see nothing out of the ordinary. When it is time to execute the attack, the payload generation phase begins. Here, attackers use LLM-enabled malware. An LLM, or large language model, is a neural network trained on vast amounts of text and code. The malware uses the LLM to mutate its own code at runtime, instantly adapting to any defensive barriers it encounters. This polymorphic capability blurs the strict boundaries between executable code and conversation. The malicious logic is self-evolving, rewriting its own instructions dynamically. The AI continuously probes the internal network. Using reinforcement learning, it analyzes feedback from its failed attempts and adapts its lateral movement strategy instantly, finding new paths to the target data. This entire cycle of probing, learning, and mutating code happens in fractions of a second, speeds that a human IT team cannot manually counter. Because the offensive automation is constantly changing its form, defenders cannot rely on recognizing static artifacts. They must shift to identifying and disrupting the behavioral patterns of the AI itself. Outside the enterprise network, AI social engineering creates a different vulnerability. Deepfake toolkits can now clone voices and map synthetic faces over video feeds, successfully bypassing biometric voice and facial recognition checks in real time. AI agents scan public data, scraping social media and breach datasets to craft highly personalized, emotionally intelligent attacks. They mimic human interactions, tailoring the message to exploit the specific fears or habits of the target. When an AI agent convinces a user to verify their profile or click a secure link, the attack is executed. The agent seamlessly intercepts the user's keystrokes and hijacks the fully authenticated session. We see a massive escalation from the 2024 baseline of retail fraud losses, leading to a projected $442 billion spike by 2026. To manage this, institutions are updating terms of service, shifting liability away from banks and onto users. Because the user officially authorizes the initial bot interaction, even under deception, current legal frameworks often dictate that the individual accepts full liability for the agent's subsequent autonomous actions. Once the funds are drained, the stolen capital is autonomously laundered. The AI routes the money through decentralized crypto exchanges or uses it to place massive orders for physical merchandise, effectively obscuring the digital trail. This movement of funds is frictionless. The capital is spent and laundered long before human security teams are even alerted to the anomaly. Top compliance officers recognize the severity of this exposure. 75% of them now explicitly view generative AI as a high-risk threat, capable of bypassing traditional compliance and fraud detection programs. The industrialization of fraud operates faster than legislation. Under the current legal framework, the financial burden of this autonomous exploitation falls squarely on the end user. Beyond software vulnerabilities, physical hardware advances present a long-term threat to global security architectures. Almost all secure communications and financial transactions today are protected by legacy systems like RSA 2048. RSA 2048 is a widely used public key cryptographic algorithm that secures data by relying on the extreme difficulty of factoring massive 2048-bit numbers. Against mature quantum processing capabilities, the mathematical barriers of RSA 2048 and elliptic curve cryptography are functionally obsolete. Attackers exploit this capability using Steal Now, Decrypt Later. Cyber syndicates intercept encrypted data, depositing it into locked vaults. They cannot read it now, but aggressively stockpile it, anticipating the moment quantum hardware can solve the encryption in seconds. Security teams seeing intercepted but encrypted data often categorize it as a failed attack. In reality, it's a deferred structural breach waiting to be activated. To defend against this, enterprises must conduct comprehensive inventories. They have to locate and map every instance of a weak cryptographic protocol buried deep within their legacy systems, their supply chains, and third-party services. This requires establishing cryptographic agility. Cryptographic agility is the ability of an organization to rapidly retire weak encryption schemes and adopt post-quantum or hybrid security solutions without disrupting their system infrastructure. Delaying these quantum-resistant upgrades does not pause the threat. It simply creates compounding technical debt, leaving vast amounts of strategic data exposed to future decryption. Reactive IT departments and linear compliance protocols cannot outpace autonomous attackers. Checkbox security methods break when hit by an adversary that constantly shifts its tactics. The architectural response is Agentic Defense. Instead of relying on alerts for human review, enterprises must embed autonomous AI decision-making directly into daily workflows. Specialized risk, operations, and compliance agents communicate across silos, assessing threats and triggering defensive actions in real time. Implementing this requires an evolution in endpoint detection and response, or EDR. This system continuously monitors end-user devices to detect and respond to cyber threats. The defensive AI shifts EDR to monitor what an application actually does, not what its static code looks like. By focusing on behavioral signals, defenders can instantly spot anomalies like unusual process creation or unauthorized outbound traffic communicating with external AI APIs. This autonomous framework transforms KYC, or Know Your Customer. KYC is the mandatory process financial institutions use to verify a client's identity. Agentic Defense moves KYC away from static, one-time onboarding events, turning it into continuous, dynamic risk orchestration. Defensive agents pull real-time data from global sanctions lists, internal database entries, and customer behavioral history. By assessing these variables simultaneously, the defense becomes a moving target that fraudsters cannot predict. AI agents orchestrate the entire pipeline, from threat detection to resolution, into a single, unified workflow. The system categorizes fraud outcomes autonomously, escalating only high vulnerability edge cases to human experts for final review. To deploy this responsibly, the enterprise must build explainable risk scoring models. Operating black box models, where decisions cannot be traced, is a severe regulatory liability. Human operators must be able to document exactly why an AI agent escalated or blocked a transaction. Technical capability must be paired with strategic integration. Cybersecurity can no longer operate as an isolated IT function. It requires alignment with business strategy and active participation in public-private threat intelligence sharing. Defenders must move higher up the pyramid of pain. As attackers rely less on static artifacts, security teams must proactively disrupt the adversary's overarching tools, tactics, and behavioral procedures. Cyber resilience in 2026 relies on structural agility. Success depends on autonomous AI architectures that observe, outlearn, and systematically outmaneuver the adversary.